Okay, so this is going to be the mandatory AI in testing talk. But before we get to what's going on today, I'll start by talking about broad history of how software testing has evolved, because I think it's really interesting to understand the way tools prior to AI-based tools today worked and how we got here. And then we're going to talk about how you can approach choosing automated tools today, because I think some amount of code and testing automation is here to stay. So we may as well get better at making the right trade-offs. And then concluding with some thoughts on what the future of testing might hold. So very briefly, testing has existed since software has existed, but very early on, it was just debugging, testing in prod, or just fixing things as they come up. And then as a distinct concept, and the first automated test generation research happened in the 60s and 70s. So that's pretty interesting. But then there was a large gap of between kind of the theoretical research and the first practical uses of what we call search-based test generation. Basically, the earlier methods of automated test generation use these just search through space algorithms to optimize their way to test coverage. And then, of course, from the mid 2010s to now, really in the past 2 years, there has been an explosion in the whole LLM-based code generation, and that has extended to test generation too, mostly because especially unit testing is more of a low-hanging fruit in code automation, because a lot of it, even before the AI days when we were writing our own unit tests, was you copy paste and modify and then you cover all your cases. So it's a good starting use case. And then last year, Meta actually did what we think was the first kind of industry scale internal deployment of your LLM-based testing. So they had pretty good results, and now it's being integrated into more industry workflows. Very briefly, the search-based testing heuristic is basically you start by generating a few sample test cases on your own, so some kind of starting state, and then you search through the search space, which is vague and depends on the algorithm, but very simply just modify an input and then check if your new test covers something else. And then the objective function in this case, I'll just use code coverage percentage as an example. There are other ways to measure how good your test suite is, but that's an easy metric. So people still use it. And then if your newly generated test suite with more tests has greater coverage than the previous one did, then you just take it, and also assuming all your tests pass. So you keep repeating the search loop until you've hit some, whatever your metric is, let's say 90% coverage. So that's just search-based testing. And then some concrete algorithms that people use for going through the search space. Hill climbing is the most canonical one, but that tend to stuck in local optima a lot. So it's been improved upon with more probabilistic optimization. But a lot of open source tools that use search-based test generation use a more genetic algorithm-based approach. So we'll cover that a bit more. And that's just using the principles of natural selection, where you have your starting candidate test cases, and they're usually represented as encoded bit strings or some other identifier. And then you do a crossover mutation reinsertion loop, which basically crossover is basically try to combine like pairs of test cases to generate new ones in like genetic terms. That's generating offspring. So you have newer cases, and then mutation is the thing that accounts for not getting stuck in local optima where you can't improve your coverage criteria. And it just introduces a bit of randomness. So maybe it goes through and changes a bit randomly that modifies one of your inputs, and that can help escape if you're stuck on 80% coverage or something. And then you just survival of the fittest, pick the test cases that collectively cover the most, and you can redo this loop for until you've hit your criteria or for some amount of time. So this has been researched and has been used since sort of the 70s and 80s. But obviously, there are limitations. Otherwise, testing automation would have been much more prevalent before the current days of LLM models. Running genetic algorithms has high computational costs because you're evaluating whole populations of candidate solutions over many iterations. And then it just wasn't a very human readable approach because you're doing all this encoding to get through the crossover mutation kind of cycle. So it proved to be a bit hard to integrate as seamlessly with your regular, like, continuous development workflows. That said, there are still a couple of tools available that primarily a lot of them focus on Java unit testing because you can automate a lot of the setup and just, yeah, unit tests are easier. And they're mostly based on the genetic algorithm approach. Check these out. But where we're heading now is your large language model based test generation, which is just generally under the umbrella of code generation using natural language prompting. So this is a loop that we're all becoming more familiar with these days. You prompt an LLM and your input would usually be like, here's my function under test or class or larger code base. And you can prompt it just to write like unit tests for whatever cases you can think of. And then usually you'd want to apply some kind of post-processing, like making sure the generated tests are passing reliably, hitting your criteria, and updating your maybe coverage criteria, for instance. And the main like human effort in this loop is refining the LLM prompt. Obviously, I think English is the new coding language. We all need to get better at being more specific with the prompting to make this actually effective approach. But I think the good thing about using prompt engineering as a shared language is it is like a unifying language between various parts of the organization, like engineers, SREs, product managers. This is an easy thing to at least conceptually understand over maybe more complicated language specific, like mocking library setups and things like that. At least for unit tests, this is getting positive outputs. But this is an area that's obviously still under research because it's still very nascent. There is still a fair amount of human oversight involved, especially with the specific language specific install, like mocking libraries and setups and like change flags, etc. So this works best when you have a starting point, like a couple of tests, and you're trying to cover maybe more edge cases you haven't thought about yet. And then there are studies that are concerned that LLMs are like maybe better at memorization than learning new things. So they tend to perform really well on the set they're trained on, but not on a set they haven't seen, like classic overfitting case. So that is still something that's under development. And then, of course, like I said before, it tends to work best for small, self-contained unit tests for different functions. So they're not really good at doing a whole end-to-end functional test that still require like human expertise in whatever your product is. On the industry scale, this is very much coming. And last year, Meta published their findings on testing out like their LLM-based test generation, which they tested on the Instagram code base primarily using automation to generate unit tests, including all of the like various edge cases and errors and things like that. And they had the whole pipeline of filtering out tests that were flaky, etc. And developers reported good results from their preliminary testing. They managed to increase the coverage of their code base by 25%. And like around 3/4 of the generated tests were actually accepted as good enough by developers. So this was pretty positive, and like so the future of this work is heading in the direction of just getting integrated with the typical developer workflow of write code, test, submit, deploy. But they can also potentially be used to auto repair like failing tests. So if your test breaks and you can use LLM prompting to figure out what's going on, that could be good too, but very much still an area of research. So obviously GitHub Copilot and some other things are open source tools that now exist. And someone also open sourced an implementation of Meta's findings. So that's pretty cool. But so picking an automation approach obviously comes with trade-offs. Everything comes with trade-offs. So having evolved from the search-based testing space with all of these computational costs, etc., to now just being able to upload your code and prompt an LLM to at least do unit tests for you, we've come a long way, but there are still pros and cons of both approaches. So LLMs obviously work best for less complicated code and like self-contained unit tests, but it tends to be higher in human readability. So it's been easier to integrate with developer workflows. There are some bias and privacy concerns because these models are only as good as the data they're given, and human data is inherently biased. So it's all based on a trust but verify kind of situation, at least right now, and maybe always. Yeah, and their accuracy tends to be higher if you've got like simple code. So more reason to keep code simplified and self-contained too. But there is also a future where these techniques can be combined into like getting more holistic coverage. Search-based testing tends to be really good at taking a whole entire test suite and optimizing towards one coverage goal. And then LLMs tend to be really good at what you might call like last mile transport. Like you've got this one like branch that you haven't been able to cover, and you can maybe use prompting to figure out what the right input to cover that is. There are tools that are experimenting with doing this sort of hybrid approach to get 80% of the way there with a search-based algorithm, and then using a prompting feedback loop to cover a little bit more. So that could be something that's interesting to explore as automation tools. This is just like the hybrid approach in action. I won't go over like it's just a sample code that bumps a version string. So you can use search to generate, let's say it generates 2 tests, but both of them are edge cases and invalid inputs. And so now like optimizing within your search space, you might get stuck because it never generated like a canonical input, but you can use LLM prompting to do that. And then like it modifies some different input. And yeah, so you can help your search-based algorithms escape being stuck with this. So what I've noticed happening now is like it's much easier and much lower of a time cost to generate more unit tests. So that's the lowest hanging fruit for automation. And obviously unit tests are good because they're low cost and they run fast. It's good that can be automated because that covers a lot of cases. And the good thing is it frees up human time and expertise to really focus on maybe narrower but higher quality integration and functional testing. So you can really cover all of the like end-to-end user journeys of your tool or your product because you don't have to pay as much time and attention to your unit testing all of the edge case kind of scenarios. So this is maybe a positive aspect. So LLM-based automation is not going to replace engineers like everybody is talking about, but it's all about balancing kind of the biases that come with automation, because you still need human oversight to pay attention to those. But freeing up human expertise and time to focus on higher level tasks is probably still a good thing, because, yeah, like I said earlier, prompt engineering is going to be a more valuable skill. And I think for when we try to poke into breakages and things like that, it's useful to have this shared language for maybe a testing pipeline or even a coding pipeline between all of these technical functions to just, yeah, it's easier to be on the same page than debugging some like obscure unit test library. So yeah, I think this could be a pretty interesting opportunity to focus on more quality functional testing. And yeah, that was it. Some references at the end, but so it's an interesting future, I think.